It is 22 November 1942. The German fighter pilot, sitting in the cockpit of his Focke-Wulf 190, has perhaps 15 seconds before his world changes irrevocably. He banks hard over the channel, chasing what his instruments tell him is a medium reconnaissance aircraft. The target is slow, relatively undefended, flying at medium altitude. An easy kill to boast about over dinner. He accelerates, closing the distance, already imagining the burst of fire that will send his prey spiraling into the gray waters below. Then he sees it, materializing from the cloud ahead, moving faster than anything his intelligence reports suggested was possible, comes something that defies explanation. It is not made of metal. It looks almost fragile, constructed from what appears to be plywood, canvas, and wood. To the German pilot, trained on the mechanically precise engineering of the Reich's finest aircraft, it appears almost improvised, almost makeshift. Yet here it comes, throttles wide open, climbing at an angle that seems to contradict the laws of aerodynamics themselves. The German cannot escape. What he does not know is that he is facing one of the war's most radical pieces of engineering, the de Havilland Mosquito, a machine that would become so feared by Nazi command that, in internal communications, they would curse the day the British learned how to make wooden airplanes fight like thoroughbred hunters. The Mosquito represented something that terrified the Nazis far more than heavy bombers or large formations of fighters. It represented the triumph of cleverness over brute force, of unconventional thinking over industrial might. The story of how this aircraft came to exist and why its mere presence could transform the strategic calculus of an entire air campaign is a journey into one of the Second World War's most brilliant and audacious pieces of design. By 1940, the Royal Air Force faced a crisis of devastating proportions. Fighter pilots were dying faster than they could be trained, and aircraft were being lost in quantities that seemed unsustainable. The Air Ministry commissioned designs for a fast bomber reconnaissance machine that could outrun German fighters rather than engage them. The specification, designated F-5/40, presented a puzzle. It needed significant bomb load capacity, defensive armament, speed to escape interception, and crucially, it could not consume the precious aluminium that fighter command desperately required. Britain, in 1940, had exhausted its conventional resources. Aluminium stockpiles were depleted. The aircraft industry was working at maximum capacity, yet output remained inadequate. The Luftwaffe's twin-engine designs, like the Messerschmitt 110 and Junkers 88, had proven the concept of fast reconnaissance bombers, but they required vast quantities of scarce aluminum and precision manufacturing that Britain could no longer afford. Into this situation came a radical proposal: build the aircraft from wood. Not entirely engines and critical components would remain metal, but the fuselage, wings, and tail could be constructed from British timber. The suggestion seemed insane. Wooden aircraft belonged to the 1920s, not modern warfare. Yet one team dared to argue that wooden construction, executed with modern precision, could produce an aircraft stronger, lighter, and cheaper than metal. Whether such a thing was possible remained unknown. Geoffrey de Havilland and engineer Ronald Bishop at the de Havilland Aircraft Company facility in Hatfield, Hertfordshire, faced an extraordinary challenge. They proposed a stressed-skin wooden construction revolutionary for its time. The fuselage employed Ecuadorian balsa wood, sandwiched between layers of birch plywood, with opposing grain directions for maximum rigidity. This seemingly delicate structure possessed extraordinary strength relative to its weight. The wings followed identical principles, balsa core protected by birch plywood skin. The wooden construction allowed dispersed manufacturing across small factories, furniture workshops, and boat-building facilities, a crucial advantage if factories were bombed. Assembly used techniques British craftsmen understood perfectly, rather than specialized riveting work that metal aircraft demanded. Two Bristol Hercules engines, producing 1,680 horsepower each, were mounted in tight nacelles, minimizing drag. The aircraft achieved speeds exceeding 650 kilometers per hour, approximately 400 miles per hour, whilst carrying bombs. The fuselage measured 12.4 meters, 40 feet 8 inches. The wingspan 16.5 meters, 54 feet 2 inches. Loaded weight was approximately 6,124 kilograms, 13,500 pounds, roughly a fully loaded military lorry. Yet, it climbed to altitudes exceeding 10,600 meters, 35,000 feet. Production became a triumph of distributed manufacturing. Components arrived from numerous suppliers across southern England. Fuselage work happened at Hatfield, wings at Leavesden, final assembly at multiple locations. If German bombers destroyed one factory, production continued elsewhere. The transparent cellulose finish protecting the wood from moisture also provided minimal aerodynamic drag. Between 1941 and 1945, manufacturers produced 7,781 mosquitoes. The figure seems almost incredible, yet it remains historically accurate, demonstrating how unconventional construction could achieve unprecedented production rates. The first operational mosquitoes entered service in mid-1942 with RAF reconnaissance units. Stripped of weapons and optimized for speed, these aircraft proved almost untouchable. Flying across occupied Europe at altitudes and speeds German fighters could not consistently match, reconnaissance mosquitoes became the eyes of British intelligence. Pilots described exhilaration tinged with tension, acceleration that pinned you to your seat, climbing rates that seemed nearly vertical, and constant awareness that a single structural failure would be instantly fatal at such extremes. By late 1942, fighter-bomber variants began operations. Armed with four 303 caliber machine guns and two 20mm cannons, plus internal and external bomb capacity, these aircraft became devastating tactical weapons. A single Mosquito could accomplish missions previously requiring 4 engine bombers with crews of 10. They attacked German shipping, airfields, and installations across occupied Europe with devastating efficiency. The psychological impact on German command was pronounced. Nazi intelligence struggled to understand how a supposed wooden aircraft could outrun their frontline fighters. Interrogation reports from captured RAF pilots were often dismissed as propaganda. German experts examining wrecked Mosquitoes seemed unable to comprehend how these materials, which they considered unsuitable for modern warfare, had been engineered into a machine objectively superior to their own designs. Internal Luftwaffe reports approached desperation when discussing the Mosquito threat. During the 1944 bombing campaign against German airfields, Mosquitoes perfected high-speed precision bombing, approaching targets at extremely low altitude at extremely high speed, popping up to release bombs with extraordinary accuracy. Specialized night fighter variants equipped with airborne radar achieved kill rates against German bombers that confounded enemy operations. By 1945, the Mosquito had become truly versatile, operating in reconnaissance, bombing, night fighting, and photo reconnaissance roles. If you are finding this interesting, a quick subscribe helps more than you know. The channel explores stories like these moments when human ingenuity overcame apparently impossible odds. Subscribe, and the algorithm might just favor you with more of them. The German response to the Mosquito threat revealed fundamental differences in how the two engineering cultures approached problems. The Luftwaffe's equivalent, the Messerschmitt 410, was a twin-engine design that attempted to replicate some of the Mosquito's capabilities. Fitted with a 75mm cannon and various armament configurations, the Me 410 was indeed a formidable machine. Yet it was heavier, slower, and required significantly more industrial resources to manufacture. Where the Mosquito weighed 6,124 kilograms, the Me 410 tipped the scales at approximately 9,090 kilograms, 20,000 pounds. The performance differential was substantial. The Mosquito could out-accelerate and out-climb the German aircraft in most configurations. More revealing still was the manufacturing comparison. The Me 410 required weeks of assembly by highly skilled workers in purpose-built factories. The Mosquito could be built more quickly, in more locations, using a more diverse workforce. A piece of German intelligence analysis dated 1943 expressed bewilderment that the enemy has succeeded in constructing a superior fast combat aircraft from materials we considered inadequate. This was not mere propaganda. It represented genuine German confusion at being outmaneuvered in a category where they expected technological superiority. The American approach presented an instructive contrast. The United States had abundant aluminium supplies and preferred conventional metal construction throughout the war. American twin-engined fighters like the Lockheed P-38 Lightning offered performance comparable to or exceeding the Mosquito in many respects, but at significantly higher resource costs. Where Britain innovated within constraint, America innovated within abundance. Both approaches yielded exceptional results, but they revealed different strategic positions. Britain had to be clever. America could be powerful. The Japanese never seriously pursued wooden aircraft construction, despite their own aluminum scarcity, largely because the technical expertise and structural understanding required had not been developed. German attempts at wooden aircraft construction, notably the Heinkel He-162 jet fighter, came far too late and never reached meaningful operational status. By the time Nazi engineers recognized the potential of wooden construction, the war was essentially lost. The Mosquito had already proven its concept on a massive scale. The Mosquito flew approximately 101,053 operational sorties between 1,942 and 1,945. Exact figures remain difficult to establish with complete precision due to lost or classified records, but by any measurement, the aircraft's operational impact was enormous. It served in reconnaissance, bombing, night fighting, and pathfinding roles, shooting down German fighters, sinking ships, disrupting airfield operations, and gathering intelligence that directly influenced strategic decisions. The psychological impact proved equally significant. German bomber crews learned to dread mosquitoes in night skies. German fighters knew that escape from a mosquito was nearly impossible. German command understood that the aircraft's presence meant their operations would be disrupted and endangered. This psychological dimension was genuine and consequential. An enemy that fears your capability fights differently, with less confidence and greater caution. That caution had strategic implications beyond mere aircraft losses. The technical achievement demonstrated conclusively that wooden construction, properly engineered, could yield military aircraft matching or exceeding contemporary metal designs in crucial performance parameters. Britain learned that innovation born from constraint could produce results matching solutions developed under abundance. This lesson would echo through aviation for decades. Surviving mosquitoes can be seen at the Royal Air Force Museum in London and the Shuttleworth Collection in Bedfordshire. Several examples remain in flying condition, maintained by enthusiasts who understand they are preserving a moment in British engineering history. Return, for a moment, to that German fighter pilot from November 1942, chasing what he believed was easy prey over the gray waters of the English Channel. In his Fokke Wolf 190, powered by a liquid-cooled engine, constructed with all the precision engineering the Reich could command, he represents a particular idea about technology and warfare. The Reich's engineering was magnificent. Their manufacturing was sophisticated. Their scientists and engineers understood aeronautical principles as thoroughly as any in the world. Yet they could not comprehend that their opponents, under pressure and with fewer resources, had chosen an entirely different path. That German pilot would have to break off his attack, unable to close on the Mosquito, no matter how hard he pushed his engine or how aggressively he maneuvered. He would watch his target accelerate into the clouds and disappear. He would have to report, in terms probably tinged with frustration, that the reconnaissance aircraft had escaped. What he would not know was that he had been defeated not by a more powerful engine or a more sophisticated piece of metal technology, but by something far more fundamental, the triumph of clear thinking over assumption, of willingness to challenge convention, of engineering born from necessity rather than abundance. The wooden wonder terrified the Nazis because it represented a truth they could not quite accept, that technological superiority could come from unexpected places, that constraint could breed innovation, that the enemy possessed not merely courage and determination, but genuine cleverness. When German command declared the Mosquito threat, they were declaring something more profound than concern about a particular aircraft. They were acknowledging that they had been outmaneuvered in the realm of practical engineering. They had presumed that metal and precision manufacturing could not be matched by wood and creativity. They had been proved fundamentally wrong. By 1945, the de Havilland Mosquito was operating in greater numbers than when the war began. It had been built in quantity that seemed to multiply impossibly. It had shot down enemy aircraft, disrupted enemy operations, gathered intelligence, and proven a concept that remained controversial until the moment it demonstrated its operational superiority beyond any possible dispute. The war ended, but the Mosquito remained, a testament to British engineering under pressure, to the extraordinary things that become possible when innovation is not merely encouraged but demanded. The remarkable thing about the Mosquito is not that it was the fastest or most heavily armed aircraft of its era. It was not. What made it remarkable was that it achieved what it achieved using materials and manufacturing techniques that conventional wisdom had rejected. The wood in its fuselage, the balsa in its wings, the careful joinery and structural engineering that held it together, these represented something far more revolutionary than mere aeronautical advance. They represented a challenge to how technology itself should be conceived. And in doing so, in the most literal and dramatic fashion, they helped to terrify an enemy that had presumed technological certainty, and in that terror, contributed to their eventual defeat.